Welcome to part 2 of the new Tabor Lucid Benchtop signal generator teardown. Today I'm going to do some RF measurements. Got the spectrum analyzer set up here, got a 1 GHz center frequency, got the resolution bandwidth set to 100 kHz, so we've got a good sweep speed over 500 MHz. So why don't I turn the RF power on now, and there we can see the carrier. So if the reference level is set to 15 dBm, and we've got 10 dBs per division, looks like our carrier is at 5 dBm, which is what the output power says, so that's all good. We've got 10, 20, 30, 40, 50, about 60 dBs of range here with this resolution bandwidth filter. I can take it down another step to 30 kHz, slows down the sweep speed a bit, but I'm really looking for some spurs in this 500 MHz span. It looks good, nice and clean. Why don't I reduce the span a little to say 10 MHz, and then really bring that res bandwidth filter down some more, so we can see some more of the noise floor of the instrument. Sorry, not the instrument. Well, this instrument, not this instrument. And you can see we can see a little bit of phase noise now, but still in terms of spurs, it's quite good. Why don't I increase the amplitude? 15 dBm is the maximum amplitude for this particular unit. Now we can see a little more of the phase noise. It's got good phase noise, by the way. On the spec sheet, we do quote the phase noise at 1 GHz at minus 138 dBc per hertz at 10 kHz. Very clean. So why don't I just now change the center frequency here to 2 GHz, so we can have a look at the harmonics. And here we can see the harmonic, and it's 10, 20, 30, 40, 50, 60, say about 58 dBc. Spec sheet says 50 dBcs from 100 MHz to 12 GHz, so that's well within the performance of the instrumentation. As I do the measurements, I do find that the spec sheet is reasonably conservative. If you want to learn more, please take a look at the Tabor website, taborelectronics.com. Look for the Lucid Benchtop signal generator and check out the spec sheet.